Hello, welcome. This is Chris Morgan. This is our 11th video in the series on creating a subtractive synth in Reactor. In the last video, we added our low-pass filter, actually a multi with high-pass, bandpass, low-pass. We added a frequency control knob, pitch tracking via the note pitch input from the MIDI keyboard, and a resonance control. In this episode, we're going to add a way to attach a envelope generator and a LFO to the frequency to give us some frequency modulation of the filter's cutoff frequency, and that'll give us an effect that's often called like wah-wah if it's the LFO, and just a general envelope generator is very iconic for synthesis. The nice thing is we've already done all the work, because the exact same code that we used in our VCA with a unipolar LFO and an envelope generator is the same code we can use for the frequency cutoff, the cutoff frequency modulation. So all we need to do is simply copy this macro, this VCA macro right here, and paste it, because what's coming out of here is a unipolar LFO and a envelope generator. Now the trick is, how do we connect that? Because we want to have the knob, and we want to have the LFO and the envelope generator. So at this point, it's good to think through the problem. The values coming out of this VCO, which we can call our filter modulation for now, are coming 0 to 1. But the values that are coming out of the frequency cutoff for the cutoff frequency of the filter, by default we're set to a depth of 5,000, 0 to 5,000. So we have to think for a second. The values that the filter responds to are in hertz. They're big values, up to 5,000 or even more, knowing that the range of human hearing is 20 to 20,000. So we're dealing with hertz, big values. The values coming out of our amplitude stuff was 0 to 1 by default, because we never want amplitudes to exceed plus or minus 1. But here's the nice thing: whenever you multiply amplitudes, though, that are going 0 to 1 or -1 to +1, they're always simply rescaled by whatever that other value is. If that other value is 1, then they will stay within 1. But if that other value is 5,000, for instance, the 0 to 1 multiplied by 5,000 will be rescaled to go 0 to 5,000. So we have a really simple fix here. We just take our cutoff frequency, add a built-in math multiply, take the output of the modulators, the cutoff frequency, and we multiply them together. Those values from the filter modulation, LFO and ADSR that I have that go to 0 to 1 are rescaled by whatever value I have as a cutoff. Whether I set it to 2,000, it's rescaled 0 to 2,000. If it's set to 5,000, it's rescaled 0 to 5,000. I hook that up, and now I automatically have some ADSR and LFO modulation of my cutoff frequency. So very, very simple, and we'll demonstrate that at work now. It's a mess down here, but I'll turn on the wrench, move the filter modulation over. I'll want to rename this tremolo to be the word wah-wah, which I wish there was a better way to say that. And the same thing, we can call this wah LFO shape, or wah-wah LFO shape. And now I have to make sure I can hear this effect. So I'm going to have, to do this, I need my sound to come in quickly. So I'm going to have a fast attack, and I'm going to have a long release, and a full sustain value, and no decay per se. So when I play the sound, and I'll sweep my filter cutoff frequency all the way up for now. So I just hear a plain old square wave, and I can adjust that here with my cutoff frequency. I can hear that sound. Now I will start with the wah-wah. I'm going to set the depth, increase the depth to 65, give it some rate, and you can hear it's a slight, it sounds like tremolo, but it's not tremolo because it's affecting the spectrum. I'll slow it down, and I'll increase the cutoff frequency. It's a little bit different than tremolo because what we hear is the high frequencies fading in and out, not the fundamental, if you listen carefully. And I can still add resonance, which sounds very different than tremolo. Okay, so there's that aspect of that, and I can change it to sine. So the wah-wah is working fine. I'm going to turn that off by bringing the depth to 0. Very easy. And now we'll do the ADSR. So I'll give it a slower attack, which means it's going to start at 0 and go up to 1 here, but that's going to be multiplied by the 1000 here. So we should hear it go from 0 to 1000 hertz. Let's make it 2000 so we'll hear a little more dramatic. And then it will decay down to this sustained level, and then I'm going to have it release more quickly than my VCA release, which means we should hear the sound when I release the key should go from bright to dull, so like an ow. Okay, so as I play this chord, I should hear the sound start with a dull sound that will become richer. And now as I release, I'll make it a little bit slower. Let's try that again. And I'll increase the cutoff frequency so we have a little bit more dramatic. Again, now it's going to go from 0 to 4400. So that works well the way that we have a fast attack for the amplitude and a slower attack for the frequency cutoff filter, frequency of the low pass filter, and we have a long release on the amplitude with a faster release on the cutoff frequency. And of course I said we got a bigger effect as we set the cutoff frequency to higher values, so that because we had a more dramatic change, and it helped to have the resonance as well. So that completes all of the parts of a basic single oscillator subtractive synth. One final touch is I'll make a quick macro here. I'll put all of the filters things inside here. This will be our first instance where we do need the inlet, because we've got to get this signal from the VCO into our low pass filter. And so there's that hooked up, and we'll go back up a level, connect, and then delete the old. Completed our subtractive synth. Now most subtractive synths, whether it's a memory moog or some other type of analog synth, they don't just give you a single voice. So what we're going to do after this is encapsulate this all and have maybe a 2 oscillator subtractive synth, and we can layer that. So now we are done.